So we're going to start out with 5.2. Again, we're starting with 5.2 just on this little cheat sheet here. So we're going to start with alternate angles. Now, alternate angles are two angles that form on opposite sides of a line that intersect two other lines. The angles are equal. And again, you might be looking at that and be like, what does that mean? I will show you in a second. Okay, so what does that mean? Basically, when we have an alternate angle, it would be something like this. I'm just going to zoom in a little bit here. So if I look at these angles here, this one on the left, if I say, hey, let's imagine this one here is 110 degrees. And remember, an alternate angle is two angles that form on opposite sides of a line that intersect two other lines. So a line that intersects two other lines, that's this thing right here, right? So this line's intersecting two other lines, which means that this angle down here is also 110 degrees, right? And if this one here is 70, that means this one here is 70. And you might be wondering, well, how am I supposed to know that? Well, what we're looking for is here, we're looking for a Z. If you can find a Z in something, you'll have alternate angles. And the Z can go either way. It can go backwards, it can go up and down. Either of them would work. So again, how do you know you have an alternate angle? You have a giant Z. If you can find a Z, you're good to go. And it can be in it can be forwards, backwards, up, down, either's fine. Now, what we also have is we have something called correspondent angles. And just like before, I'll give you the definition and we'll explain what that means. So these are angles that occur on the same side of it's called a transversal line. We'll learn what that is today. So angles that occur on the same side of a transversal line are equal. They're the same. So corresponding angles, when we look for these, we are looking for F's. And so you might be wondering, well, what the heck is a transversal? So we're looking at a transversal line. So basically a transversal line, and this is in your workbook here, so you don't need to write it down, is a line that intersects two or more lines. So just like before, this what I'm highlighting here is our transversal line. So I have a transversal line that's intersecting two parallel lines. And it's saying that, hey, the angles that happen on the same side are in fact equal. So I'm looking for an F like this. And I can see that, hey, if this angle here is 110, that would mean this angle under here is 110. Yeah, I'm going to change the color on that one. And just like before, we can set this, we can have this F go forwards, backwards. We can have it go upside down. We can have it go upside down and backwards. All of those options will work. So again, if this one over here, if this angle is 70, I mean this one is 70. If this one up here is 70, that would mean this one over here is 70. So again, our corresponding angles, we're looking for an F. We also have co-interior angles. And these interior angles are if two lines are parallel. And a parallel line means that it's never going to touch, right? If you think about a parallel line, think about like the yellow stripes on a highway. They always have the equal distance away from each other. They'll never touch no matter how far you drive. So if two lines are parallel, we call them the co-interior angles, add up to 180 degrees. So when we're looking at this, what we're looking for is either a C, but technically it's going to be more of like a blocked one. Like these are the same thing. So if I'm looking at this one here, well, I can see that I have found these lines are parallel. I know these lines here are parallel. I'm just going to zoom in for a second. I know these lines are parallel because we have this little marker here, these little blue markers. That tells me those lines are the same. They are parallel lines. They'll never touch. Doesn't matter how far they extend, they will never touch. So if I go, I can find myself a nice little C here. What does that mean? It means that these two angles, if this one's 110, that means this one has to be 70 because both of these need to add up to be 180. The co-interior, they share the inside. The inside angle of the C adds up to 180 degrees. If you know one of them, you will automatically know the other. And just like before, you can have a forward C, you can have a backward C. If this one's 70, that means this one has to be 110 because they have to add up to 180. You can also have them where they're rotated. Again, any orientation of it works. But I'm just looking at the inside ones. So if this one's 110, this one down here has to be 70. And finally, we got one more. We have vertically opposite angles. These are also sometimes just called just opposite angles. So you'll see these interchangeably. If you see an opposite angle, it means vertically opposite. So what a vertically opposite angle definition is, basically angles that are opposite of each other at a specific vertex. Again, we'll break this down. And are created by two intersecting will be equal. So angles that are opposite each other at a specific vertex and are created by using two intersecting lines will be equal. We'll explain what this means. So, okay, so again, so what the heck does this mean? A specific vertex that are created by two intersecting lines. Well, if I have two lines, does not matter which ones, I'm just going to draw two random straight lines. This is where they intersect, right? And it's saying that, hey, angles, if I tell you that this one up here is 120 degrees, it's also going to mean that the one opposite of it here is 120. Which would make this one 60 and the one opposite of it 60. It does not matter how they intersect or how steep they are. You know, if I give you one like this, these two little small angles here will still be the same. It does not matter how they intersect. So what are we actually looking for here? Technically an X, but any intersection will work. I'm going to use the word X just to kind of like, because I have a little way to help you guys remember this afterwards. And you might be like, well, I can't really find an X in here. Well, you can actually. There's two of them because there's two intersection points. I'm looking for intersection points specifically. I see a big intersection point right here, and I see a big one right there. So if I tell you that, hey, this one over here is 70 degrees, that means this one down here, which is opposite of it, is also 70. If I tell you this one over here is 110, means this one over here is 110. So using these four things and the knowledge that, hey, a straight line is 180 degrees, we can kind of use that now in a bunch of different ways, which is kind of where we're going with this today, tomorrow, and probably Friday. So you might be wondering, how the heck am I supposed to remember all this? Let's make sure everyone has the stuff written down. So we got four different things here, right? We have a Z, an F, a C, and an X. We have a Z, an F, a C, and an X here, right? We have four different things. So how can you remember that? I like using like just a little like a phrase, I guess. Zebras sorry, zebras fight crying x-rays. Right, I just made like a weird sentence with the first with all those different things. You're looking for Z's, F's, C's, and X's. Okay. So a bunch of different things here. We're going to end up using this throughout the course of the unit here. But now we're actually going to start going into our official topics. So we're going to go ahead and navigate back to our sheets. This is on page 189. I'll give you just a quick couple seconds to get there. Okay, so basically, so we're starting with quadrilaterals and transversals and all this fun stuff. And what's a transversal again? A transversal is a line that intersects two or more lines at distinct points. Two or more lines at distinct points. And now specifically, when we get parallel lines that are intersected by this, we're going to get different angles. And that's where a lot of these properties start to form. If you know the lines are parallel and you know one of the angles, so if you know one of the angles and you know the lines are parallel, you can figure out every other angle in that shape. So you just need an angle and you need to know they're parallel. So if I give you this shape here, and it tells us that, hey, line 1 is parallel to line 2. This is line 1 here. This is line 2. What's the measure of all of these angles? Well, here's what I know. I know that. Let me fix that. I know that in a straight line, these have to add up to 180 degrees, right? So number 1 and number 2 need to add up to 180. If that's the case, well, that means this one over here has to be 105. You could also start using some of your properties over here. But same thing for number 3. Well, this is a straight line, right? Which means these two angles, number 2 and number 3, need to add up to 180. So that means this one's 105. Or you could be like, oh, I have an intersection point. These are opposite angles. I have an X. An X will work. So there's different ways you can find this information, which would mean this one over here is also 75. And again, if you're wondering where I got 105 and 75 from, it's because the straight line has 180 degrees, and I'm just subtracting those numbers from it to get the other one. Okay, well, what about down here now? Now is where we have to start using some of that stuff. So if I'm looking for different letters here, I could use, again, zebras fight crying x-rays. I see a Z I can use. I could use a Z. I could make an F here as well. I see that's there. I see there's a C there, and I see there's an X there. Either one of them work. I'm gonna form a C here, which means this is a co-interior angle, right? Which means 3 and 6 would need to add up to 180, which would make angle 6 75 degrees. Oh, now I have a new angle. I know I have a straight line here. That means this one has to be 105. Oh, I have a straight line here, and I now have an X. So there's a bunch of different ways you can solve this information. So we could go in and like show our work down here if you wanted, but all of this kind of comes down to the fact that we have just one final one, which we don't really like putting a name to, but a supplementary angle. Basically, on a line, it's 180 degrees. That's all you need to know from that. You don't even need to go to like the official like mathy description of it. You just need to know straight line, 180 degrees. So, okay, let's try up in the difficulty a little bit with this. Let's go down a page, 2 pages, sorry, to page 191. And let's try this one. It's going to want us to find angles 1, 2, 3, and 4 is what it's asking us. That's just 2 pages ahead on page 191. So first thing I really want to mention, though, I'm just going to scroll up 1 second. What are we always looking for? We are looking for lines that are parallel, and if we know one of the angles. I see I have 2 parallel lines here. Line 1 and line 2 are both parallel. And I know one of the angles of something in there. I now can solve the rest of them. So if I'm looking at angle 1 here, Again, there's a bunch of different ways you could go about this. If I'm going to go at them just in the order they given to me. So angle one, well, if I'm trying to figure out angle one, I want to make one of those four shapes, a Z, an F, a C, or an X. Well, I see right here, I can make a nice Z, which tells me that, hey, that's an alternate angle, which means that if they form on opposite sides of a line that intersects two other lines, oh, that's this one up here, this one going up and down, it's intersected two lines, the angles are equal, which would mean this 110 is equal to angle one. So I would say that, hey, angle one, oops, is equal to 108, 110 degrees, because I know it's equal there with a Z. So you might be wondering, well, what about angle two now? Well, I'm trying to now come up with different ways I can make a shape from it. Again, a Z, an F, a C, or an X. I see here I can make myself a nice F that's going to have it under it. And an F is a correspondent angle. Angles that occur on the same side of a transversal line, that's this line going up and down, are equal, which means if this one's 120, it means this one's 120. So what about angle three here? Well, I could try and make a shape, but I see here that I have a straight line, which would mean angle two and angle three equal 180. What's 180 minus 120? You get 60. So angle three would be equal to 60 degrees. And again, all of these have multiple ways of solving for them. This is not the only way to do it. There are lots. This is 60. And then for angle four, just like before, I can see, oh, both of these need to add up to 180. So 180 degrees minus 120 degrees. Going to give you 60. Again, other ways you can do it. You could see that there's like a Z there. You could do it as an F. That would work too. Bunch of different ways. So I'll give you 1 minute. Try out question two. 1 minute. Try out question two. So again, think if there's any of those letters you can find. Think about if there's any supplementary angles or straight lines. So again, a couple different ways you could do it. You could recognize that, oh, there's a Z here, which would mean this angle would be the same. You could then use that straight line as an option. Maybe you found yourself a nice a C here. So you know that, oh, these need to add up to 180. So that's 123. And oh, I have an intersection here, which would mean that this is the opposite angle of it, which would mean this is also 123. So there's a bunch of different ways you could go about doing this. But overall, it's going to be equal to, we would say angle 1 is equal to 123 degrees. Okay. So where is this going to come together? How does this help us with four-sided shapes? Well, that's kind of where we're going into here next. So on the next page, what you're going to find is you're going to find a map of every four-sided shape. And it's going to show some of the qualities of it. Now, if you're looking at this, you'll be like, oh my God, I'm never going to remember this. That's okay. You don't need to. We can always break the shape down. I'm also never going to ask you like, is this a right trapezoid or an isosceles trapezoid? I'm not going to ask you that. You're not going to be asked that by your test either. What you do need to know, though, is you do need to recognize when a line is parallel, which might mean one is probably going to involve, if you see that symbol, it's recognizing it, or just kind of knowing it based on it. And two is knowing that, hey, like, you know, obviously a rectangle has all right angles in it, stuff like that. So those are the types of things that we are looking for. You do not need to memorize these. You probably won't even need to refer to this that much at all. But it's just visualizing some of the properties of these shapes. The one thing we do really need to know from this page, however, though, is one, we need to know that a quadrilateral is a closed four-sided figure. So it has four sides. And we also need to know, and this is the big one, is that the sum of the interior angles is 360 degrees, right? So if I have this shape here, it's just a random shape. If I have angle 1, 2, 3, and 4, I need to know that angles 1, 2, plus 3, plus 4, it has to be 360 degrees. Just like a triangle, all the angles add up to 180. In a quadrilateral, a four-sided shape, all the angles add up to 360 degrees. So that's the really big one, is you need to know the 360 degrees. You can always break down a really difficult shape by looking at it. I could look at this and be like, oh, now I have a triangle here, or I have right angles and stuff. So you can always break down hard shapes later. But the big one here is we need to know that sum of interior angles is 360 degrees. So let's start applying this stuff. Let's apply our ZFCX and let's apply the sum of the interior angles, and let's actually start looking at some shapes here. So the first one here is it wants us to find a couple different things. It wants us to find the length of AC. It wants us to find angle A, and it wants us to find angle B. And then it also wants us to list what type of quadrilateral this is. So a lot of information, a lot of stuff being asked. So here's what I know. I know these two angles are the same. I know it's a parallel line. AB and CD are parallel lines. I could go up here and I could recognize that, oh, this is an isosceles trapezoid. The two lines are the same. And those angles are the same. So this is technically an isosceles trapezoid. This is not the thing I really care a lot about. Again, you're not going to be asked, what kind of shape is this on your exams and stuff? But that's the shape it is. So let's start finding some of this stuff. So let's find the length of AC. Oops. Well, for AC, because it is an isosceles, trapezoid, that means that AC is equal to BD. We know what BD is. BD is 4 centimeters long. So again, isosceles trapezoid, these two lines here are the same. That's how we know that if this one's 4 centimeters, it means the other one's 4 centimeters. It has, they call it congruent legs. So check, I've done that. Now angle A. So I'm going to show you guys a little trick here. All the stuff we were doing up above, it had extended lines. You can extend these lines. You can draw little imaginary extensions to it. To all of these lines if you really wanted. And that gives you a little bit more of application of those shapes that we've all kind of learned here. Now, alternatively, you could also recognize that, oh, this is a straight line, which means that these angles need to add up to 180. Alternatively, you might also be like, oh, there's a C here, which means these two angles need to add up to 180. Which would mean that angle A is just 180 minus 60 degrees. So that means it's going to be 120 degrees. So just like before, there are going to be a bunch of different ways you can solve. Oh, sorry, angle A. The same concept can apply to the other side. I can make myself a backward C here. You could also realize that, oh, this is a straight line. That means this needs to add up to 180 degrees. You could make yourself a C this way too. Actually, no, sorry, no, that won't work. That won't work. Apologies. Because that has to be two parallel lines. That would only do one. So, but if I know I can do a C this way, well, that means this one's also 120 degrees. So angle B is also equal to 120. So I've solved all four things of these. This question's asking them. So what about for question B? What we have here is we have I'll go and look at my chart. I can see I have a kite here, which means those two lines are the same. These two lines are the same. These are all right angles in here. So let's look at this a couple things. So for question B, it wants us to find WX and angle XYZ. I'll explain what that is in a second. And then it wants us to find the sum of these two angles. So it wants us to find three different things. So let's start with WX. That's this line here. So you could end up using probably trigonometry to figure this out if you found enough stuff in here. But because I know it's a kite, I know that these lines up here are the same, which means if this one's 2 centimeters, this one must also be 2 centimeters. So WX is equal to 2 centimeters. And that's because WX is equal to XY. Those two lines are the same. So now it wants us to find angle XYZ. And so if you're thinking about that, you're technically finding the middle angle there. So if I start, let me erase everything up here. If I start from angle X, I work my way to Y, and then it goes to Z, it wants me to find the angle that connects those 2 points. So it wants me to find all of this information here. So we want to try and find angle X, Y, Z. So I'll give you a couple seconds. Think about what that angle could possibly be. What could angle Y be? So the only angle I know in this thing is that this one's 101 degrees. So you could think, well, what if I extend this stuff? That's never a bad thing to try and think about. In this case, it's not actually going to help us that much. We can't find any shapes that are actually going to work here. I can't find an F. I can't find a C. There is an X, but that doesn't actually help me. And I only know that these ones are all 180 degrees. So we have to use the properties of the shape in this case. I have to know that this kite, because we have a lot of similar shapes here, if this angle over here is 101, it means this one over here is 101. So basically, angle XYZ is the same thing as angle XWZ, which would mean that angle XYZ is 110 degrees. Because that's what, sorry, 101 degrees. Because that's what the XWZ is. Now, the next question it asks us is, what's the sum of WXY, WX and Y, this angle, and YZW, this one? Basically, hey, what's the other two angles? That's what it's asking, right? What's these two angles now? So I'm going to give you 30 seconds. Just think about that. Think about how could you find that? How can I find these two angles? Okay, so how can I find this out? Well, here's what I know. I know that in a shape, all four sides have to be 180 degrees. So I know that we call this the sum of interior angles has to be 360 degrees, right? Of a four-sided shape, of a quadrilateral, right? All four angles need to add up to 160, or sorry, 360. What I know is that if these two are the same, that means those two would be the same. So why can't I take 360 degrees minus 101 minus another 101? That'll give you 158 degrees. It's not asking me to find each separate one. It just wants to know the sum of these two. What's both of these combined is 158 degrees. So I took what I know. I know that all four need to add to 360. I subtracted the ones I did know to find what I did not. You can always use what you have in there to find what you're missing. So I'm going to give you a couple minutes here. Try out question 3, try out question 4. I'll give you guys about like 5-ish, 6 minutes, something like that. Oh, sorry, just question 4. Don't worry about question 3. So I'll give you about 3 or 4 minutes here. Try out question just 4. Okay, so just going over this assignment here. I'll pass this out to you right away, but this is it. This is the purple sheet for those of you online. Yeah, this is due on, oh God. I think we're gonna do the 5th, March 5th. It's due on March 5th there. And we're also going to have a concept check for this unit on the 4th. So March 4th will also be a concept check. But so yeah, so you can keep finishing up this booklet, and then you can work on those questions. You will have time for it this week, though. Don't worry about that.